Good morning, children. Sairam. So, let us get back to chapter number 6, An Education in Science by Stephen Hawking. Children, before starting or before just jumping into this chapter, I would actually ask one question again. The question was, what do you think is this story about, or what actually is the writer conveying the readers? Can anyone tell about this? Can anyone think and tell what is this? What does the writer wants to say? Can you tell? Last time in the last class of English, we discussed about the science. Like about the science means about the importance of science. How Stephen Hawking has told that what is the criteria of science, what is the criteria about science towards people, by the people, of the people. How do the people think about science, what actually science is, and what is the, what you can say, importance as well as the significance of science in our lives, in our basic lives. Does science imply to an important subject only, or science relates to an important ethic of life? What is the basic nature of science? That is it a subject, or it deals with the only practical or theory based techniques? Fine, let's just get back to the textbook, scroll through some lines, and then let's get back to the story. The way, not story actually, it is not a story, I told you. It is part of the essay which was written by Stephen Hawking. Fine, this is page number 56, and right now we are on the last paragraph. What can be done to harness this interest and give the public the scientific background it needs to make informed decisions on subjects like acid rain, the greenhouse effect, nuclear weapons, and genetic engineering? Clearly, the basis must lie in what is taught in schools. But in schools, science is often presented in a dry and uninteresting manner. Now, the basic thing is that yes, science. What is the criteria of people towards science? The writer tells the readers that the attitude of the public is ambivalent or bifurcated one, that is divided. It's not fixed. That is when people are actually thinking about science, which is a big word. It is a term which is really very wide. You can't explore science in just a small word. Science doesn't mean that you will be comprising, or it comprises of only cosmos or some chemical reactions or invasions of chemicals or elements. No, it is a vast word, and it has different dimensions. It has different bifurcated, divided, separate dimensions which deal with different dissected portions of life. Science does not only deals with your chemical formulas, your polymerization, your carbon compounds. No, science is a big, broad, wide term. It deals with different types of, you can say, terms and terminology. But what is the problem? Why people have a divided or ambivalent type of nature towards science? Because they themselves do not know that what is the basic concept of science, why we are involving science in our lives, or why we have involved, or why the latest developments have involved science in the latest techniques. What is the functioning of science? That is why they take it as a small term. They think it is just an subject. Okay, I'll take an example, live example of your lives. Fine, it is very common. Children, when you actually pass out your 10th standard, what happens? Many of you are inclined towards science stream, right? But how many of you know that what actually deals with science stream? What you have to do with science ahead? What is science stream comprising of? You want to be doctor, but you do not know what you have to do with the doctor, with the course content of the doctorship. How, which stream you want to go for. You don't know whether you want to become a neurologist, whether you want to be a psychiatrist, whether psychologist, or you want to be a surgeon or a gynecologist. When you do not know such terms, how can you decide the basis of your life? Just because you got 80 on 80 or 100 out of 100 in science subject, it does not makes you a qualifier for science subject. Children, that is the main perception when we talk about the science stream or science section. It needs to be dealt with full diligence and full sensibility. That is what Stephen Hawking is now going to discuss more. Children, learn it by rote. By rote, kindly underline by rote. What does it mean by rote? To pass examinations and they do not see its relevance to the world around them. By rote means memorize. That is to cram, to mug up. Fine. And that is to just learn whatever the teacher has given you. You are just simply learning and learning and learning. You're just cramming. You do not understand what is the basic concept involved, and you're just pouring it into your mind. Whatever is coming into the lines, line by line, word by word, you keep on mugging, irrespective of the fact what is necessary and what is not necessary actually. Now, moreover, science is often taught in terms of equations. Sorry, student. Science is often taught in terms of equations, although equations are a concise and accurate way of describing mathematical ideas. They frighten most people. When I wrote a popular book recently, I did not write any book recently. It's not me. It's the writer Stephen Hawking. I was advised that each equation I included would have the sales. I included one equation, Einstein's famous equation E is equal to mc square. I repeat, Einstein's famous equation E is equal to mc square. Maybe I would have sold twice as many copies without it. Now what happened? He was configuring out a particular manner in which science is being taught and it should be done. And being an author, when he was composing this particular book, he was asked by the publisher or by the compiler that you should not include such things. You should include formulas and theoretical more equations which will actually double the sales. But what is the writer's perception? He says that no, I did not wanted to earn sales. I wanted to write a pure form of concept. Scientists and engineers tend to express their ideas in the form of equations because they need to know the precise values of quantities. But for the rest of us, a qualitative grasp of scientific concept is sufficient, and this can be conveyed by words and diagrams without the use of equations. The science people, now please pay attention children, it is an important and really necessary part of your this lecture, that what actually is science and what is the actual concept of teaching science and learning science. The science people learn in a school can provide the basic framework. I repeat, if you are having textbooks with you, please underline this line. The science people learn in school can provide the basic framework. But the rate of scientific progress is now so rapid that there are always new developments that have occurred since one was at school or university. That is now the author is saying that the science children are learning these days is totally different. It is actually very different. What they are learning and what is necessary to the environment, what is required for the environment is totally different. When they are actually, they means the children who are learning in the school, they learn the basic facts, but they are not able to provide the in-depth education, in-depth formulation of this subject. I never learned about molecular biology or transistors at school. Nobody. But genetic engineering and computers are two of the developments most likely to change the way we live in the future. Popular books, magazine, articles, etc. about science can help to put across new developments. But even the most successful popular book is read by only a small proportion exactly of the population. Only television can reach a truly mass audience. There are some very good science programmers on television, but others present scientific wonders simply as magic without explaining them or showing how they fit into the framework of scientific ideas. Producers of television science programs should realize that they have a responsibility to educate the people and not just entertain. That is, Stephen Hawking says that it's not that when we are dealing about science terms and terminology, we need to be just scientific in terms. No, it is not. See children, when we are talking about inventions and discoveries as well as innovations, every innovation, every discovery has been carried out by only one thing, that is your own curiosity to know how. The curiosity to know how actually enables you to develop or execute your plans into a fresh one. This is the way a particular person learns a lot. Till then, thank you so much. For now, I will put a pause over here, and I would like you all to get back to your textbooks and read whatever till I have taught you. Go through the text again, once again, and then we'll continue with this. This was your part 2. Just wait for the part 3. Thank you children, and Saira.